So let's do the test here. About the jet test. The first one, data below is taken from normal population. So come from test to see. Okay. So the null hypothesis is the mean is 124 and alternative is mean is not 124. And it is known the population standard deviation, which is 10. 5% significance level. We have 5 data here. So now we go to spreadsheet and put the data here. 122, 134, 138, 128, 129. So here we, So go to menu and statistics and stat test. So we perform the jet test. Now we have data. There are 2, data or stat. If you know the mean of your sample, then you go for stats. But if you have only data like now, then you go for data. So now we go for data and okay. So mu 0 population mean is 124 and sigma is 10. And list, we have our list on A column. So A. So alternative hypothesis is like there are 3 options, but now number A is like mu is not 124, which is a two-tail test. So we go for this one. And okay. So this is our result. So the p-value is 0.166, which is larger than 0.05, which is a significance level. So mu, the p-value 0.166 is larger than 0.05. So accept AC0. We cannot reject AC0. So we accept AC0. And there is no sufficient evidence to claim that null hypothesis is not true. Number B. Actually, this is the same, but I'll show you a different way of solving. So number B is 11.0, 9.4, blah, blah, blah. So I'll go for the calculator. We have only 5 data, so we can make it easy list here. No need to go to the list like just now. So you need this bracket and 11.0, comma 9.4, comma 11.9, comma 12.1, comma 10.3. But you need to name it. So when you click Control and VAR together, Control and VAR. I mean, no need to put them like at the same time, but Control and VAR. Then you will see this store. And you can see this arrow on your screen. Let me call it AAA. So this list, I name it as AAA. So let's go to menu and stat test, jet test. So now still I have data. So mu 0, 12.2, and sigma 1.3, and 1.3, and list. Now we just found AAA. Or you can select from here, it's the same. And frequency list, we have only data, each of data is just 1. So alternative hypothesis is still we have this two-tail test. Okay. So the p-value is 0.03, 02. So smaller than 0.05. So reject AC0. We have enough, like sufficient evidence to reject AC0. So this is the one. You can try number C. Number 2, pot of paint should cover 24 square meter of wall. The test, we have 32 samples and the average 23.3. So this is X bar. So we have the X bar may follow the normal distribution, which is 24, comma, so 1.8 square root 32 squares. But our result is 23.3. So now we will test it, how this goes with 5% significance level. So it says the less than 24. Oh, there's a sub questions. So number A, why it is possible to use z-test in this case? We have sufficient, like enough samples, like more than 13. When we have more than 13, usually it follows normal distribution, and we can use z-test. We call it central limit theorem. And also, we know the population standard deviation, which is another very important factor. So in this case, null hypothesis is mu becomes 24, and H1 is mu is smaller than 24. And determine the p-value for the test. Since I already defined the distribution, I will go for the normal CDF. So go for statistics and distribution and normal CDF. So we want to know, so now we have like this, and this is 24. All the tests always assume that null is true. So at this moment, we have this X bar distribution, which is 24. And now we have 23.3. And we want to know which like probability, what probability can we get this 23.3 as a like extreme level. So this is negative 999 and 23.3, mu 24, and standard deviation 1.8 over square root 32. Okay, so this is our p-value. Oh, I made mistakes. 24. So this one 0.0139, which is p-value, is smaller than 0.05. So conclusion from the test. So now we have the p-value which is smaller than significance level. So there is so we reject H0. So there is sufficient evidence at the 5% significance level that the average coverage of the paint is less than 24. So this is our conclusion. Yep. So number D, critical region for this test. So now we have everything, and we want to know 5% on the left side, which is critical level. So we go for inverse normal. So statistics, distribution, and inverse normal. Area is 0.05, standard deviation 24, and mean is 24, standard deviation is 1.8 over square root 32. So number D, critical region is 4. X bar is smaller than 23.48. Let's see. So this is the one. So that's why, since we have smaller number, which is 23.3, so our result is in critical level, which is rare to happen. So that's why our result is like result H0. Number 3. It is known that the time between arrival of two buses normally distributed, standard deviation 2.1. Bus claimed that mean 8.3 minutes. John believed, in fact, longer than this. Okay, So now is mu 8.3, but actually John doesn't believe it. He is thinking this is larger than 8.3. So he collect the data, these 5 datas, and mean sample. So let me just put those data again. So we needed this bracket, 8.0, 8.7, 9.2, 8.4, 8.5. So, oh, come on. So now another like a store, like a control and VAR. And let me call it again AAA. So now I use the same name for AAA, but now from now on my AAA is the list of this. So this is the list. So mean, we can find the mean from here. So here, statistics. So list math, list math here, mean, AAA, enter. So we know our X bar. Eventually the distribution X bar will follow normal distribution with 8.3, 2.1 over 5. This is our distribution, and our result comes 8.56. So distribution, this is the answer for the C. And let's find this one. So here 8.3, this is X bar distribution, and we want to know 8.56, larger than 8.56. Always we are trying to find the extreme level. So if you have 8.56 and we want to know larger than 8.3, I mean the alternative hypothesis is like that, alternate hypothesis, then we need to find the probability from 8.56 to the right side. So we go for statistics and stat distribution, normal CDF, lower bound 8.56 and 9999, mu 8.3 and 2.1 over square root 5. Okay, so now we have 0.39, which is larger. So 0.391. So write down the conclusion of Jones test. Actually, just now we found p-value. P-value is larger than 0.05. Actually, it doesn't say about the significance level. When it is not written, usually we assume that 5% significance level. Of course, if you have some other like reason to apply like 10% significance level, you can do that. But just I'm saying generally we do 5% significance level. So this one 0.39 is larger than, larger than this 5%. So the conclusion is fail to reject. Is 0. So there is no sufficient evidence to claim that the average time of the buses, the time between the arrival of 2 buses is longer than 8.3. So we don't have that evidence. So verify by performing the test. Okay, let's do the test. So now go to statistics and stat test and z-test. We have data AAA, so 8.3. So this sigma is population sigma. This is not the 2.1 over square root of 5. This is just 2.1. And least we have AAA. And now I have alternative hypothesis is like we have 8.3 is mu 0. This is null. So now we are claiming that larger than mu 0. So we need to select this one. You need to select it properly, because if you don't select it properly, the result is different. So like this. Oh, so we found the p-value here is the same as we found. So we verified it. So the p-value is 0.39. So again, fail to reject is 0. And critical reason for this, stat distribution inverse normal. So now we assume that 5% significance level again. So we want to know what is the 5% on the right side. Here, 5%. So always this is not inverse normal. We need to find the area on the left side. So we need to input 0.95. And 8.3, 2.1 over square root 5, because because we are now we are dealing with this distribution. So in this case, the sigma, we need to put the sigma for x bar, not the population sigma. So now we found, okay. So critical reason is x is larger than, x bar is larger than 9.8448, let's say. So our result is 8.56, which is smaller than 9.84. So fail to reject. A is 0.